Hi, I'm Alex. I'm a software developer with VitalSim, and in this video I'm going to be giving a quick introduction to coded track, which is a type of communication equipment used in railway signaling. So here I've got a basic diagram, and we've got a segment of track, and on either end of that segment of track we've got insulated joints. So these resistors mean that electrically this piece is isolated from this piece, and this piece is isolated from this piece. So generally speaking, for coded track, you're going to have an interface card connected to either end. So that's what I'm showing here with this box, where you've got two lines on that interface card connected to each rail on one end, and the same thing on the other end. So these coded track circuits are bidirectional, and that's why I've shown pulse being transmitted from left to right here, and right to left here. I've also shown 3 copies of this waveform being transmitted, and that indicates that when these coded tracks transmit signals, they're going to transmit them redundantly. So if you want to transmit a code 2, it's going to be transmitted redundantly 3 times before that's accepted on the other side. Okay, so this is a real basic model of what it looks like when there's no train present. So it's a high resistance between the two tracks on the rail. So this means that if you transmit some voltage or you apply a voltage across this rail, it's going to be maintained from one end to the other. When there is a train, the voltage applied across the rail will allow the current to short through the axles, and this means that you will not necessarily see a voltage appearing here on the other end. So this is what you would call a segment of track being shunted. And that means that there's a low resistance between the tracks created by the axles. So this scenario is detected by the coded track, because when you try to apply some pulses across the 2 rails and you don't see anything on the other side, you can infer that the segment of track is occupied by a piece of train or shorted. As an aside, shunting has multiple meanings. So in the previous diagram, a segment, the current was shunted from one side of the track to the other, whereas this is what it looks like when a train is being shunted from one piece of rail to another. So shunting can refer to either current being shunted through an axle or a train itself being shunted. Coded track is often used as a boundary condition. So what I mean by that is if you have complex interlocking with many routes here on the left side, and maybe further down to the right you have another complex interlocking, you want to isolate what's going on for testing. So let's say, for example, you're not changing anything further out to the right, but you're making some changes on your signal logic here on this interlocking to the left. So in order to simplify your testing, you can cut your simulation off at this piece of coded track and treat it as an input, which means that you don't have to set up the configuration to create that coded track signal. So to give a little bit more detail about what I mean by that, generally the coded track signal that you're receiving in here is going to be dictated by the configuration of the interlocking out here to the right, which is not shown. So to create a particular coded track input signal, you have to set up the interlocking out here to the right in some configuration to yield that particular code. So instead, if you cut your simulation off here, these inputs just become user-defined, and it simplifies the testing for this part of the interlocking to the left. So this is just helpful to clarify when people are talking about this. You have track circuits, which are the most general concept, and basically that means some kind of electrified circuit, and that can be as simple as just a binary occupied, unoccupied detector circuit. And then you have coded track circuits, which are generally more complicated, and they transmit more than one bit from one end to the other. And then you have electrocode, which is a popular proprietary type of coded track circuit. So here we've got a track plan. Everything here is already set up, and these symbols here represent coded tracks. So you can see in this particular location, we have 1, 2, 3, 4, 5, 6 pieces of coded track. These ones out at the end are like what I was talking about earlier, where they're basically a boundary condition for this simulation. So the user is able to set up the values of the input on the coded track here as desired for testing, rather than thinking about having to set up conditions on an interlocking in order to generate those codes. Whereas these pieces of coded track here are actually simulated as being in communication. So in order to generate certain coded track inputs on this piece of coded track, it's necessary to cause the outputs on this piece of coded track to transmit those codes. Okay, so we can see here in this icon, there's a 1 and a 2 which are illuminated on the outgoing side, and a 1 and a 2 which are illuminated on the incoming side. So that means that this segment of coded track, the interface card on it, is currently transmitting a code 1 and a code 2, and receiving a code 1 and a code 2. So it's receiving the same thing that it's transmitting. And you can see down here, this kind of is the same situation where you have this piece of coded track transmitting a 1 and a 2, and this piece of coded track receiving a 1 and a 2. Another thing I'll point out is that when you hover over a piece of coded track in this layout editor, you can see the values of the coded track signals. So here you'll see that there's 2ZT underscore C1 in. So when a code 1 is being received by this piece of coded track, the tag with this name will be picked in your simulation. Okay, so I'll just briefly show you what the configuration for this piece of coded track looks like. So for example, if you've just done a new layout and you've added a piece of coded track and you want to know how to set that up, for one thing, you can position it, obviously. So you basically are going to put that wherever it makes sense according to your layout. And then when you right-click the icon, you'll see that there's a whole bunch of configuration options here. And essentially here you have lists of mappings between tag names and those coded track values that are transmitted between ends of a segment of coded track. Okay, so hopefully that was helpful. And remember to like and subscribe. And if you have any questions, please leave a comment below. Thank you.